Hi everyone, this is Mr. Ong from Asterie Tuition Center. Today we are going to assemble a motor and explain to you how the motor works. You will need a round dowel, a long coil of wires, two connecting wires with a battery, preferably a big one, 1.5 volts. Some foam to stick and act as your conductors, two big paper clips. Lengthen them by unfolding so that the ends of them look like this. You will need a strong bar magnet and one small plastic tube to hold the paper clips together. So prepare your coil. This is prepared by winding your wire, winding a long coil of wire about 30 times round a cylindrical object, okay, and tying them up as shown here. Make sure that the ends of the wire are well centered and straight. Then get a piece of sandpaper and sand the top half of each of the ends of the wire until they are shiny. Make sure that there is no enamel at all on the top halves of the wire. Okay? Shiny, not shiny. Alright, once you have prepared this, we are good to go. Okay, so we will need current carrying conductors. They are your paper clips here. So insert your paper clips one by one first. Insert one, then put your coil and close the loop as shown here. Make sure that the paper clips are almost at the same level. When you are done, your electrical coil should be roughly vertical. Hold the paper clips in place with a small plastic straw or tube. Okay, so you have set up the coil as shown here. Complete the circuit by joining the coils or the paper clip to your battery or your power source. Okay, secure them tightly. One side at a time. Okay, as you can see here, take your time to do this because the experiment is very interesting. Alright, one last step. How do you make a motor? Yep, in your chapter Electromagnetism, you have encountered that when you pass electricity through a magnet, you will get a force. So to complete this whole experiment, insert your magnet into the center of the experiment. What should we do next? Right? You may need to tap or give a twist to the coil to let it get started. Is this enough? As you can see, it's starting to go already. Alright, so it didn't need my help after all. Okay, so have a close look at your homemade motor. How is this working? Think for a moment, try and apply what you have learned in your electromagnetism. Think about your Fleming's left-hand rule, think about your Lenz's law, and think about induced current. Okay, so now I'll give you the explanation on how the motor works. Okay, so to clarify, this motor that we see here is actually a half motor. Okay, why? Because half of the coil is an electromagnet. Half of the coil is an electromagnet. This happens when the sender region, you remember that we sended half of the coil? Yeah, this occurs when the sender region is touching the paper clips. Okay, to show this, you may take a compass or magnet near to this and it will change the direction of your compass. So when the enamel side, which is the one with the paint, is pressed against the paper clips, it is not an electromagnet. When the colored side or the part where you did not sand is touching the paper clips, I repeat, it is not an electromagnet. You can do this again by putting a compass near to this. There will be no change in the direction of the compass needle. Okay, so this is how the on again, off again of the coil creates motion. When the coil is an electromagnet, when the sender part is touching the paper clips, it is an electromagnet. It turns to line up with the bar magnet. Okay, and the motion begins. Just as this happens, the colored part, the part that you did not sand, they touch the paper clips, so electricity stops flowing through the coil. Then at that moment, the electromagnet is off, but the coil is moving. Okay, so the inertia makes it turn just a bit more so that the sender part touches the paper clip again, and you will see that you will get a force. This makes it turn yet again. So half the time the coil is an electromagnet and moves to line up with the permanent magnet below, and half the time the coil is just coasting. So what we have done here is a half motor. In a full motor, the coil is never off. Okay, so a further explanation. The marvel of the motor is that a coil and a magnet will turn electricity into motion using your Fleming's left-hand rule. Remember, your father, mother, child. Force, magnetic field, current. When you have current flowing at 90 degrees to magnetic field, you get a force. So in this case, your current is flowing from positive to negative. It is going in this direction. Your magnetic field is going from north to south in this direction. And so the force on the coil at this point is upwards. Thus, it will rotate in this direction. Okay, so further things you can do is to connect a light bulb in a loop to this in series with this motor. Okay, so what will happen is that if you connect a light bulb to this circuit, your light bulb will flicker. Okay, it will go on and off. This will demonstrate the on-off pattern of the coil as it rotates. So half the time, when the sender sides of the coil are against the paper clips, electricity is flowing through the coil as well as the bulb. The bulb is on. As electricity flows through the coil, it becomes an electromagnet. Then this electromagnet lines up with the bar magnet before, below. So remember, unlike poles attract and like poles repel. So the magnetic poles going through the coil center will turn the coil's face towards the permanent magnet. Okay, so just as this is happening, the electricity turns off because the enamel half of the coil's leads do not conduct electricity. No electricity can flow through the coil or the bulb. The coil acts as a switch. When an electricity flows through the coil, the bulb is off. The coil stops being an electromagnet, but the coil will just keep moving. Just like a child on roller skates, the coil keeps on rolling after an initial push. Once in motion, the coil stays in motion. I hope you have understood how a motor works. Thank you for watching.